Okay. So now we'll move on in ellipse. What all have we done till now? We've done the equation, the conjugate ellipse. Okay. Latus rectum, focal distances. Okay. And have we done the property of focal distances? That the sum of the focal distances always is constant, and that is equal to 2a, semi-major axis. No, major axis, sorry. Yeah. So A is semi-major axis and 2a will be the length of the major axis. And what else? We started with tangents. I think we derived the equation. Yeah. So equation of tangent in slope form is given by y is equal to mx a square m square plus b square, right? In the Cartesian form it will be x(x1) upon a square plus y(y1) upon b square is equal to 1. Just write this down. Whenever you have an ellipse, x square upon a square plus y square upon b square is equal to 1. The equation of the tangent will be given by this. x(x1) upon a square plus y(y1) upon b square is equal to 1. Okay. What are x1 and y1? Yeah, so these are the point of contact. Okay. So let's suppose ellipse is given by this x square upon 4 plus y square upon 1 is equal to 1. Okay. And the points are x is equal to root 2 and y is equal to 1 by root 2. Okay. Can you find the tangent at this point? Does this point lie on the ellipse? Yes? Just satisfy it. Put x is equal to root 2. What are you getting? 2 upon 4, 1 by 2. And after this you are getting, what is the value of y? Y is equal to 1 by root 2. So it is also 1 by 2. 1 by 2 plus 1 by 2, 1. It's satisfying. So find the equation of tangent at this point. So what will you do? Replace this x1 with root 2 and y1 with 1 by root 2 and put the values of a square and b square. Got the answer? Okay. So if we put the point x1 over here, we'll get x times root 2 plus divide by 4 plus right y(y1) upon b square. The value of b square is 1 and this will be equal to 1. Okay. So x upon 2 root 2 plus y upon root 2 is equal to 1. This will be the equation. You can take the LCM 2 root 2. This will become 2y. So you will get x plus 2 root 2. Okay. So Next question, write down. Find the equation of tangent to the ellipse x square plus 3y square is equal to 3, which is perpendicular to the line 4y is equal to x plus 3. Understood the question? So equation of tangent which is perpendicular to this line. Yes? Y is equal to 4x. That line won't be perpendicular to this one. M1, M2 should be equal to minus 1. Minus 4x. Okay. So y is equal to minus 4, you'll be getting minus 4x. Got the answer? Yes. So the equation of the ellipse will be x square upon plus y square upon 1. So try to convert it into the standard form x square upon a square plus y square by b square is equal to 1. Try to make the RHS is equal to 1. Okay, so divide all the sides by 3. So the value of a square is 3, b square is 1. Okay, and we know that, yeah. So here you can see that what is the slope here? 1 by 4. So y is equal to 1 by 4 x plus 3 by 4. So if you compare this equation to y is equal to mx plus c, right, you can see that this portion, the coefficient of x will be the slope and this will be the y-intercept. So the slope will be 1 by 4. So here the slope of this line is 1 by 4. So therefore the slope required will be m into 1 by 4 is equal to minus 1. M is equal to minus 4. Okay, so the required tangent will have the slope of minus 4. And we know these values. And we know the equation in the slope form, equation of tangent, y is equal to mx plus minus root okay, just put the value of m, a square and b square. So y is equal to minus 4x plus minus root 3, ठीक है. So a square is 3 into m square is plus 1. So what are you getting here? 7, 49, right? So square root of 49 will be 7. So y is equal to minus 4x plus minus. So this is the answer. Will there be one answer or two answers? There will be two answers. Okay. Will any answer be rejected? Just think of it. Graphically try to think. If you see an ellipse, and if I say draw two tangents perpendicular to this line, okay, so I think two tangents are possible. One at this point, other here. Okay. And if I say, so that's why I get plus minus sign over here in the case of ellipse. Similarly, in a case of circle, two tangents can be drawn like this. Okay. But in the case of a parabola, if I ask you, yeah, only one tangent can be drawn. If I ask you draw tangents but parallel to one line, so only one tangent can be drawn like this. So that's why in this equation I get y is equal to mx plus a by m. I don't get any plus minus here because only one tangent is possible. Okay. So next write down chords of ellipse. So we'll try to derive the equation for chord for ellipse. So it will be very easy if you get these 2 points. If you know these 2 points on the ellipse, then you can easily put the equation of line in 2-point form. Remember, if you know these points, can you form a line from these 2 points? You can apply the slope form y minus y1 upon x minus x1 is equal to y2 minus y1 upon x2 minus x1. Right? If you have the parameters here, a cos theta 1, b sin theta 1 and a cos theta 2, b sin theta 2. Can you try to find the equation here in the parametric form? Just try it out. So it's a similar case, you have to apply that thing only, y minus y1 upon x minus x1 is equal to y2 minus y1 upon x2 minus x1. And you have to do some manipulations. So we'll get y minus b sine theta 1 upon x minus a cos theta 1 is equal to b sine theta 2
minus sin theta 1 upon a cos theta 2 minus cos theta 1.
Okay,
Yes, sir.
this is a simple equation of a line in 2-point form. Y minus y1, x minus x1, y2 minus y1, x2 minus x1. So we can apply CD formula here. Do you remember? From trigonometry in 11th. So here this will become,
2 sin c plus d by 2 cos c.
yeah, 2 sine c minus d by 2. This is sine c minus sine d. So this will become 2 sine c minus d by 2 cos c plus d by 2. Remember the formula or should I write it down? You remember it. Okay. So 2 sine theta 2 minus theta 1 by 2 cos theta 2 plus theta 1 by 2 divide by a 2 sine theta 2
Plus
plus
theta
theta 1
1 by 2 cos sin theta 2 minus theta 1 by 2.
theta 1 minus theta 2 by 2.
बड़ा minus आ गया.
See, this is cos c minus cos d. That is equal to 2 sine c plus d by 2 sine d minus c by 2, if you remember.
Yes, sir.
So this is an exceptional formula, cos c minus cos d. Remember?
Yes, sir.
So I'll write this down. Sin c plus sin d. Tell me. 2
Sin
c plus d by 2.
cos c minus d by 2.
Okay. Sin c minus sin d.
2 sin c minus d by 2 cos c plus d by 2.
Cos c plus
C
cos
by
d.
2.
Cos c minus d.
Minus d by 2.
So in the formula of cos, I am getting both cos here. When they are getting added, when they will be getting subtracted, I'll get both signs. Cos
C minus cos d.
2
2
sin.
sin c plus d by 2 sin d minus d by 2.
Yeah. So this part is most important because I am getting d minus c over here. Okay, not c minus d. In all the rest of the cases, I am getting c minus d, c minus d, c minus d. But in the case of cos c minus cos d, I'll get d minus c over here. Right? So that's why I wrote theta 1 minus theta 2 because theta 1 will be d here. Okay. So something will cancel out, I think.
Sin.
These two will cancel out, leaving a minus sign, leaving a negative sign in the front. Because this is negative of this, right? If you take a minus sign common and take it outside, because sine minus theta is equal to minus sine theta. Okay, then they will cancel out. So yeah, then solve it. After that, hmm,
Cos theta 2 plus theta 1 by 2.
yeah, cross multiply then. So y minus b sine theta 1 Okay. So what next you can do is you can convert this into cos upon sine, right? And then you can cross multiply. So final result which you will get is x upon a cos theta 1 plus theta 2 by 2 plus y upon b sine theta 1 plus theta 2 by 2 is equal to cos theta 1 minus theta 2 by 2. So this is the final equation of chord which you will be getting. X upon a cos theta 1 plus theta 2 by 2, y upon b sin theta 1 plus theta 2 by 2 is equal to cos theta 1 minus theta 2 by 2. Okay. Got this? So if you have an ellipse, there's just one thing to remember. Can you see the slope? The slope here is equal to minus b by a cot theta 1 plus theta 2 upon 2, right? So if I take some parallel chords over here like these, so these are some parallel chords. Let's suppose the ends of these parallel chords are theta 1, theta 2. Ends of these parallel chords are theta 3, theta 4. And here we have theta 5, theta 6. Just till here. So let's suppose these all chords are parallel, right? So their slopes will be identical. Do you agree? All the parallel lines have the same slope, right? So their slopes are same, which means that the value of minus b upon a cot theta 1 plus theta 2 by 2 is equal to minus b upon a cot theta 3 plus theta 4 upon 2 is equal to minus b upon a cot theta 5 plus theta 6 upon 2. So that means this value, this expression, minus b upon a will cancel out. That is common in all of them. So this portion will be identical in all these. Are you getting it? Yeah. So the slope of this line is equal to minus b upon a cot theta 1 plus theta 2 by 2. And the slope of this line is minus b upon a cot plus theta 4 by 2. So these must be equal since the slopes are equal. So therefore cancel these, right? So you are getting cot theta 3 plus theta 4 by 2 is equal to theta 1 plus theta 2 by 2, right? So therefore we can say that theta 1 plus theta 2 will be equal to theta 3 plus theta 4. Okay. So is equal to theta 5 plus theta 6. Okay. So this is a very important property, that the endpoints of the endpoints of the parallel chords of an ellipse, okay, the sum of the eccentric angles will be constant. Sum of the parametric coordinates will be constant. Okay. So write down at the endpoints of the parallel chords, at the endpoints of the parallel chords, the sum of the eccentric angles will be constant. Yeah. At the endpoints of the parallel chords of ellipse, the sum of the eccentric angles will be constant. Okay. Like how? This? Okay. You have a problem with this? Is it okay? Visible? Okay. So now see, the limiting case of a chord will be a tangent. Can you explain this term? The limiting case of a chord will be a tangent. So when does a chord become a tangent? Instead of 2 points, which means, yeah, exactly. So instead of theta 1 and theta 2, I will have only 1 point, right? So in this case of a tangent, theta 1 will be equal to theta 2. So if you put theta 1 is equal to theta 2 is equal to theta, let's suppose. So what are you getting? See, x by a cos theta, y by b sin theta is equal to cos theta minus theta, cos 0, which is 1. So x by a cos theta plus y by b sin theta is equal to 1. I think we have done this equation, the equation in of parametric form. No? So today we derived one equation, if you remember, x1 upon a square plus y1 upon b square is equal to 1. Remember this? We got this. Now see, x1 can be put as a cos theta 1 or a cos theta, and y1 can be b sin theta. So if you put these values, what will you get? See, if you put this as a cos theta, you will get x cos theta
by A
plus y sin theta
by B.
is equal to 1. So this will be the limiting case of a chord. If you put theta 1 is equal to theta 2, then you will get this equation, which is actually the equation of tangent. Okay. So this is the third kind of equation of a tangent. Equation of tangent in parametric form. Okay. Any problem till here? Sure? Okay. Next, write down director circle. So do you remember this concept from circles? Anyone? Do you know what a director circle is? What is it? Look back if you can find it. Have we done circles? I think we just did a parabola, right?
Sir had already Rehan had completed.
Okay, he has completed. Just check it out if you have it in notes. Otherwise, we'll do it. Okay, in the case of circles as well. Check out the chapter circles.
Director circle of any curve is the locus of a moving point such that the tangents drawn from it to any given curve are
Are
mutually
perpendicular.
perpendicular.
Okay.
And director curve for a circle is concentric to the given circle whose radius is root 2 times the radius of the given circle.
In the case of circle, yeah, it's specific. Okay, so write down the definition again. Locus of a point from which the two tangents drawn are mutually perpendicular. So don't you revise your notes? Yes? No? You should at least know that is it in your notes or no, right? See, do you get the definition? It's easy. In the case of circle, I want to see a point from where the two tangents are perpendicular, right? So let me assume a point like this. So this is the point. So the two tangents are perpendicular. Okay. This angle is 90 degree. This angle is why? And this angle will be 90. All the angles will be 90, right? What is the, this is radius, this is radius. Okay, so this becomes a square. Can you see this? This is first a rectangle because all the angles are 90 degree. Then the two adjacent sides are equal. Therefore, it becomes a square. So all the sides are equal. So what is this distance? This will be root r square plus r square. Yeah, root 2r. Okay, or r root 2. So now see that this point will be moving like this. The point from where the tangents are perpendicular will move like this. Similarly, I'll have a point over here. The two tangents are perpendicular. Same story again, right? So it will become a concentric circle. Concentric circle means the center is same with the radius root 2r. Okay, if you have the circle x square plus y square is equal to r square, the DC, the director circle will be x square plus y square is equal to 2r square. Okay, this is just in the case of circle. So how do we derive this thing? In the case of circle, we have y is equal to mx plus minus a root 1 plus m square, right? So let's assume this point as h comma k and put this h comma k over here. So you will get k minus mh is equal to plus minus a root 1 plus m square. Now square both sides. Okay, after squaring both sides, you will get a quadratic equation in m. If you can see, you're getting m square over here, you will get m square over here. So you will get quadratic equation in m, right, which has two roots. The two roots will give you the two slopes of the tangents, right? And you know that the product of the slopes will be minus 1. So if you equate the constant term upon the coefficient of x square, coefficient of m square is equal to minus 1, you will get this equation. Try it. If in a quadratic equation, if you have am square plus bm plus c, what is the product of roots? C upon a. Okay. So like this is the equation of tangent we studied. Now since the tangents will be passing through h comma k, I'm putting this point h comma k in here. If I square both sides, I'll get k square plus minus 2 mhk is equal to a square 1 plus m square. Okay, or I can write this as a square plus a square m square. Question. So see, you understood this? Okay, so director circle is actually a circle from which the two tangents will be perpendicular. If I take this angle as 90 degree, this angle is also 90 degree, this is also 90, this is a quadrilateral, so this angle is also 90. Okay, or you can do it like this angle is 45, this angle is 45. Okay, since these two triangles are congruent, if you remember it from the 10th standard. So this is r, this is r, this will be root 2r. So therefore I got the circle x square plus y square is equal to 2r square. Other way of doing it is, if I take this point as h comma k, okay, and I write the equation of tangent, I got this equation, right? Quadratic equation in M. If we rearrange the terms, I will get m square h square minus a square minus 2m 2hkm 2hkm plus k square minus a square is equal to 0. This is the quadratic equation in M. Okay, the product of roots is equal to minus 1. So you get k square minus a square upon h square minus a square is equal to minus 1. Okay, so if you open these terms, you will get h square plus k square is equal to 2a square. Okay, in the last step you will replace h comma k with x comma y. Understood? If you cross multiply, you will get,
Equated it with -1.
because the tangents are perpendicular.
But we have used C upon A.
Yeah, or that is the product of roots, right?
Then like M and M2 is the product of the slopes of the tangent.
Yeah, so these are the two slopes. The two slopes will be the roots of this equation. Okay. Similarly, if you do the same process for ellipse, okay, the only difference will be you will be getting root a square m square plus b square here. Okay. In the case of ellipse, you will be getting y is equal to mx plus minus root a square m square plus b square. And if you square both sides, you will get a square m square. This term will be identical. Okay, here you will get bus b square. This will be the only difference. So this will be b square. Here this will be b square. Okay, and here this will be b square. And in the final answer you will get h square plus k square is equal to a square plus b square. So this will be the case of ellipse. The only difference between circle and ellipse is, here you are getting a square m square plus b square. In the case of circle, you will get a square m square plus a square. That's how we get a common. Okay. So this will be the equation of equation of director circle of an ellipse, right? H square plus k square is equal to a square plus b square. So if we try to see this thing with reference to an ellipse, this is an ellipse. Okay, the director circle will be a circle going like this. Okay, so it will be a circle with center same as the center identical to the center of the ellipse, but the radius is greater than the major axis or the semi-major axis. This will be equal to root a square plus b square. As you can see, this is a circle and the radius is root a square plus b square. Okay, so this is a director circle, and we also discussed one more circle, auxiliary circle. Okay.
Diameter is equal to the major axis.
Yeah. So this is the auxiliary circle, and this one is director circle. Okay. What will be the director circle of a parabola? Can you try to find it out? You have the equation y is equal to mx plus a by m. So in the case of parabola, you have y is equal to mx plus a upon m, right? Let's say the tangent is passing through the point h comma k. So you'll get k is equal to, try to do the same thing. Try to form two tangents which are perpendicular. किस चीज़ की इक्वेशन है? What is that line called? Directrix. Yeah. So you get m square h minus k times m plus a is equal to 0. Right? This is what you'll be getting. So if you see m1, m2, that will be equal to a by h. This is equal to minus 1. So you get h is equal to minus a. Replace h comma k with x comma y. X is equal to minus a. So this is actually the equation of the directrix. So in the case of parabola, the directrix will be the equation of the director circle.
But then why are we calling it a circle then?
Yeah. So it's not a circle actually. So in the definition C, we have written locus of points, okay, from where the tangents are perpendicular. Okay. In the case of circle and in the case of ellipse, these are circle. Even in the case of hyperbola, it's a circle. But in the case of parabola, it's the directrix. It's not a circle. Okay. Just write this down. In the case of parabola, the director circle is the directrix of the parabola. Okay, so the director circle is not necessarily a circle. Okay, in the case of parabola, it's not a circle, it's a straight line. Okay. Next, write down equation of normal. So this is the ellipse. Let's suppose we need to find the normal at this point. A cos theta, B sin theta. Okay. So this is a normal. The normal and tangent are both perpendicular. Okay. So these both will be perpendicular. Now see, the slope of the tangent. Can you tell me what is the slope of the tangent here? You know the equation in parametric form, x upon a cos theta, y upon b sin theta is equal to 1. One other way of doing it is, now you will be learning calculus in your 12th standard. So whenever you have x square upon a square plus y square upon b square, any curve in the form of x and y, in the terms of x and y, right? And if you want to find the slope is given by derivative dy by dx. Can you find out the derivative here? Just find it out. So differentiate both sides, okay, and see what you are getting. So to find the slope, sometimes you need to find the derivative. Minus where are A and B? They are constants, but okay, let's see. So if you differentiate this, you will get
2x.
upon a square. What? Okay, if you have this term 3x square, so what is the derivative of 3x square?
6x.
A similar thing is applying here. This is a constant, this comes out of the differentiation. That doesn't mean the differentiation of this is 1. Okay, so if you do the derivative here, you know the derivative of x square, this is 2x
2x by a square.
by a square.
2y by b square dy by dx.
So 2y by
b square dy by dx.
differentiation of 1 is
0.
0. So see the value of dy by dx. So 2 cancel out. Okay, minus b square x upon a square y. Can you see this? Minus b square x upon a square y. Just rearrange the terms. And if you put the values x and y, so x is a cos theta and y is
b sin theta.
b sin theta. So dy by dx becomes minus b square a cos theta a square, which gives you minus b by a cot theta. And even you can see from here, what is the slope here? Minus the coefficient of x upon the coefficient of y. Remember, in the case of a straight line. So this is the slope of the normal, right? Now can you find the equation of the normal? It will be y minus b sine theta x minus,
A cos theta minus B by cos theta.
so this will be the equation of the normal. Just rearrange the terms and make it more presentable. Got something? This equation. This is the equation of tangent. That's not possible. Something else. See? Cross multiply.
Say AY sin theta plus B cos theta is equal to
AY sin theta.
plus B cos theta is equal to AB.
There's something wrong.
तो क्रॉस मल्टीप्लाई करके क्या है?
Yeah. Okay. Okay.
सर वो इसमें नहीं आ रही क्योंकि स्लोप को उल्टा करके लिखेंगे तो इस रिजल्ट में
Ha, exactly. There's one mistake we did. See, this will be the slope of the
tangent
tangent. We need the slope of the normal. So slope of the normal will be, that will be equal to a by b tan theta. Okay. So this is the slope of the tangent. This will be the slope of the normal. Yeah, that will be the same equation of the tangent only. Okay. So this is A upon B tan theta. Can you see now? Now cross multiply. Then you will get, let's see. We get by minus b square sine theta is equal to ax tan theta minus a square cos theta into tan theta. Right? If you convert all of these into sine and cos, so you get sine theta upon cos theta
So d minus cos theta minus ax sin theta is equal to sin theta cos theta into b square minus a square.
Okay. So this is what we are getting, right? Minus a square cos theta into sin theta upon cos theta. Huh? No cos theta here. Okay. What will cancel out? You're getting cos theta over here, right? Okay. Now we take LCM cos theta, and then we'll get by cos theta so you get ax so this is the equation of the normal. Okay. Done till now. Let's do a question, a previous year IIT question. Okay. So just do it with full concentration. Try to solve this. So it's from IIT Advanced. It's a comprehension. So tangents are drawn from point 3 comma 4 to x square upon 9 plus y square upon 4 is equal to 1 touching ellipse at A and B. Find the coordinates of A and B. So this is the first part, find the coordinates of A and B. The second part is find the orthocenter of triangle PAB. Just try to do these two parts. So this was a comprehension of 3 questions. I've written the 2 questions out of them, 4 marks each. Yeah. one question. Can you apply that formula? X(x1) upon a square plus y(y1) upon b square is equal to 1. Yes? Why? So that formula is only applied, okay, you can also write this down. That formula is only applied if the point is on the ellipse. Okay, that is if the point is the point of contact. Okay, if the point is outside, then you can't apply this formula. If the point is outside, then if you apply this formula, you get this chord of contact. We'll come to this later after this question. Okay, so in this case, that formula can't be applied. X(x1) upon a square plus y(y1) upon b square can't be applied, because it is only applied when the point is on the ellipse. Okay. So you can use the slope form in here. You know the slope form? Y is equal to mx plus minus root a square m square plus b square. Try to use that. Yeah. Actually, if you write that equation, now you know that the tangent will be passing through the point 3 comma 4. Then you put the point 3 comma 4. You will get an equation in M. Then solve that equation. You will get the two tangents. Just half. Two values. What's the equation final? Okay, other one cancel out. Okay, good. M square cancel हो गया तो slope 0 नहीं होगा. हाँ, good. It will be not defined, infinity. See, so you're getting the equation of tangent is y is equal to mx plus minus okay. So if you put the point 3 comma 4 here, you get 4 is equal to 3m.
9m square plus 3 plus 4.
Square both sides. Okay. First you take it to LHS, then you square. So I'm skipping that step. So you get 16 plus 9m square plus minus 24m. Okay, so from this 9m square cancel out. Okay, and you get 24m is equal to 12. M is equal to half. Okay, so one of the slope is half. Let's try to imagine the picture. So let's suppose the ellipse is like this. This point is 3 comma 0 and this point is 0 comma 2 and the point 3 comma 4 is over here. So one of the tangent is visible from here. It's pretty clear. It will be this line, the line parallel to the y-axis, and the other tangent will go something like this with the slope half. Okay, understood this thing? So from this point, two tangents can be drawn. One is this, other one is this. This point is A, this point is B. Okay, so you got the coordinate of A. This is 3, 0. Can you find the coordinates of B? Just think. Try to brainstorm how can you get the point B. Anyone? PA will be equal to PB. You will get only one equation from there. If you put this point as x comma y, right? Equate the distances. Then you'll get just one equation. From there you can get other equation. Okay, you can try this out. Some other method. So you know. Ellipse की equation satisfy. Okay, you get equations, you can solve it. But let's see some other way, some simpler way. So you know the equation of this tangent will be the equation with the slope half, right? So if you put m is equal to half, you will get plus minus root okay. What is this? This will be 5 by 2, right? So you will get this, or you can write this as x minus 2y plus 5 is equal to 0. Okay. Now if you see, let's suppose this point is x1 comma y1. Now with the parametric form or with the Cartesian form, if you know this point x1 comma y1, can you find the equation of tangent at this point of contact? That will be equal to xx1 upon a square plus yy1 upon b square is equal to 1, which means I'll get xx1 upon 9 plus yy1 upon minus 1 is equal to 0. Okay. So this is equation of tangent, equation of the same tangent. These two equations should be identical. So compare the coefficients. How will you compare? These ratios should be proportional. Okay, so 1 upon x1 by 9 is equal to minus 2 upon y1 by 4 is equal to 5 upon minus 1. Okay, from there you will get the points x1 and y1. Okay, those methods are okay, but I think this will be much simpler. Okay, understood till now? Any doubts? So first we wrote the equation of the tangent in slope form. Okay, we know the slope, we just found it. Slope is equal to half. We know a square, we know b square. We finally get this equation, x minus 2y plus 5 is equal to 0. Now in the Cartesian form, if you know the point x1 comma y1, okay, you can replace x square with xx1, y square with yy1, right? And you get this equation, xx1 upon 9 plus yy1 upon 4 is equal to minus 1. Now what you can do is, these two tangents are same. This is the equation of the same tangent. Therefore, the coefficients should be proportional. So after taking the coefficients, you will get 1 upon x1 by 9 is equal to minus 2 upon y1 by 4 is equal to minus 5. Okay, so now equate one by one. So first equate this thing to minus 5. So you will get x1 is equal to minus 9 by 5. And similarly equate this thing, you will get y1 is equal to 8 by 5, right? Can you do this? So since these both are variables and they are equal to some constant value, so we can equate this to minus 5 and this thing to minus 5 again. and you will get the values. Understood? Understood till now? Any doubts? So this point will be, yeah, how did you get this 3 comma 0? That's a doubt. Now see, this is a tangent. This is visible very easily. If this is a point, if I want to draw a tangent and this line, okay, is just touching the ellipse, since we know that this will be the tangent at this point, at the vertex, okay, so therefore it will pass through 3 comma 4. Therefore this line will be the tangent and this will be the point of contact. Okay, so if you see the tangent at 3 comma 0, it will pass through 3 comma 4, obviously because the equation is x is equal to 3. Yes? Any doubts? Or you can use that, since the m square term got cancelled, okay, you can deduce from that the m will be equal to infinity. Since m is equal to infinity, slope is equal to infinity, that will be a line parallel to the y-axis. Okay, so how did we get that infinity? If you want to explore that, you can put m is equal to 1 upon t something. Okay, got this answer? Everybody is clear how we got the values of x1 and y1? So we got the equation. What was the equation in m square? We got 6.
24m is equal to 9n square plus 4.
So if you put m is equal to 1 by something, let's say p, so what will you get? You will get 16 p square plus 9 minus 24 p is equal to 9 plus 4 p square. Okay, so from here you get 12 p square is equal to 24 p. So we're getting two roots, p is equal to 0 or p is equal to 2, right? So either 1 upon m will be equal to 0 or 1 upon m is equal to 2. Okay, so this gives me two values of m. Sorry, I think this is not visible. So from here you get 12 p square is equal to 24 p. So p is equal to 0 or p is equal to 2, right? So if p is equal to 0, 1 upon m will be equal to 0, which means m is equal to not defined, infinity. Hence this tangent, other tangent will be of the slope half. Can you do the next one? Orthocenter of triangle PAB. Try it out. Have you noted this down? Okay, in the question which was asked in IT, there were 4 options. Okay, I'll give you those 4 options because that will make things very easy. So if you can deduce from the options only that what is the orthocenter, that will be a good thing. So first option is 5 comma 8 by 7. Second is 7 by 5 comma 25 by 8. Third is 11 by 5 comma 8 by 5. Last is 8 by 25 comma 7 by 5. So these are the 4 options, A, B, C, D. So tell me which one is the answer. Of course you will have to do some calculations. No, I don't think we need the ellipse anymore because we are just considering the triangle PAB and we know the 3 coordinates. right? So can you figure it out? Now see, I don't need the ellipse because I know all the three coordinates. So the three coordinates are, first one is 3 comma 4, then we have 3 comma 0, and then you have
minus 9 by 5, 8 by 5.
first of all, are you aware of all the centers? Ortho center, circumcenter, incenter and centroid.
Yes, sir.
Are you clear? What is ortho center? Point of intersection of
Altitude.
altitudes. Okay, so ortho center is the point of intersection of altitudes, right? So that means this point is P, A and B. So if you draw altitudes, okay, then the point of intersection will be the orthocenter. Okay, see very carefully which altitude is easiest to find here. Which equation of altitude is easiest to find here?
PA. Just from point A.
From point A, like this, or from point B? From point B. Now see how we find the orthocenter. The process is, you know this point, okay? If you know all the three coordinates, then you can form a line from here, okay? Or you know the slope of this line, okay? You know the slope of the line PA. You can know the slope of the line perpendicular to PA, and it will pass through this point, okay? That is one equation of one altitude. You know the slope of line AB,
And the point P.
right? And you know the point P. You know the slope of line AB, you know the slope of line perpendicular to AB, and it passes through P. That will give you the second line. The point of intersection of these two lines will be the orthocenter. In this case, see, this question was asked to confuse that you calculate all the equations. But what you could really do is, see, this line, okay, the altitude will be perpendicular to this line, right? And it will pass through this point B. So this will be the altitude, right? What will be the equation of this altitude? This is a line parallel to the x-axis. Since this is a line, y is equal to
8 by 5.
8 by 5. This is clear, right? So that means the coordinates of all the points on this line will be 8 by 5, and orthocenter will be one of these points. So that means wherever we have, yeah, so wherever we have y is equal to 8 by 5, that would be the answer. So answer will be C, 8 by 5. Got the answer? If you since want to find the value of x1 as well, then you can assume some other equation like this, okay? Then you know the slope, you will know this slope, you will find this equation by putting this point, right? And then you make them intersect. They'll meet at this orthocenter. But in this case, it was very easy to find. It's clearly seen. And then the next part was, the third question was, what is the locus of the point whose distance from the point P and the line AB is same? I'll write the question, but that will be your homework. Locus of point P have you seen the previous year question papers of IIT? Yeah, you have that book? No? So I think you should see that. Try to solve the previous year questions, at least starting from 2000 to 2017. Okay, write this down in the front of your copies. Okay, that you have to do, that you have to solve the question papers of the previous year question papers of IIT starting from 2000 to 2017. Either you can do them topic wise, you can get some books, okay, or this will be in your study material as well, I guess, or you can get some books who have segregated all the top this questions topic wise, or you can simply get the question papers from internet, right? Just Google them, you'll get it. So this is the third part. Locus of point whose distance from P and AB is same. That will be a parabola, right? Very good. Now see, if the locus of a point from a fixed point and a fixed line are equal, then the locus is equal to a parabola, and the parabola will go like this, something like this. Since its distance from this point is equal to the distance from this line, this point will be known as the focus, and this line is the directrix. Can you form the equation now? It's very easy. Okay, that's your homework. This point, assume this point as h comma k. Okay, now this distance sp is equal to sm. Okay, you will find the equation of the straight line, and you will see the distance of this point from the straight line, and you will apply distance formula over here. Okay, you will get this distance, equate the distances, then you solve it. Okay. Have you done this? Let's move on to the next question. Where?
Auxiliary circle at the point M. उसके बाद
Then the area of triangle with vertices at A, M and O will be if you haven't written the question, just write it down. I'll be raising it now. Okay, so this is the point A, point B, so let's say this is the auxiliary circle. Okay, forget this area. Then this is my point M. Is this clear? The equation was x square upon 9 plus y square is equal to 1. This was the equation. What is this point?
3, 0.
And this point will be
0, minus 1.
0, minus 1. Good. So you have to find this point. Okay. What is the equation of this circle? Is equal to a square, right? So x square plus y square is equal to 9 will be the equation, right? Now, what can we do? Anyone? You can you get the parametric coordinates of this point?
A cos theta is sine theta.
3 cos theta, 3 sin theta. It lies on this auxiliary circle, and the equation is x square plus y square is equal to a square. So this point can be 3 cos theta, 3 sin theta. Can you think of something now? What can you do? There are two things which you can do is, the longer way is you find the equation of this line, right? You can easily find this out. X upon 3 plus y upon minus 1 is equal to 1 with the intercept form. You know the x-intercept 3, y-intercept minus 1, x by 3 plus x by a plus y by b is equal to 1, right? And then you can make it meet the circle, this circle, okay? And then you can find the point of intersection. You'll get two equations. One is the equation of line, one is the equation of circle. Just solve them. Or what you can do is, you know that this is a straight line, this is one straight line, okay? This ABM is a straight line. Therefore, the slope of AB should be equal to slope of AM, right? This thing you can use. So that will make things easier.
Sir, will it make a difference if we consider the point B on the other side?
No, it's okay. It will be
It will be minus 3 cos theta.
no. It will be 3 cos theta, 3 sin theta.
Even if we have considered it for
Yeah. It will be same. No, actually, the theta angle is according to that. Now, see, in the third quadrant, both are negative, right? So if you put any angle theta, you'll automatically get cos theta is equal to negative. You don't have to induce that, right? So you don't have to worry about the sign. This cos theta and sin theta will worry about the sign. Okay, you give this an input theta, it will decide whether this will be positive or negative. The parametric coordinate is always a cos theta, b sin theta, no plus minus. So you get slope of AB is equal to 0 minus minus 1 upon 3 minus 0, 1 upon 3, and the slope of AM 0 minus 3 sin theta, 3 minus this. So you get sin theta upon cos theta minus 1. So this is what you are getting. Sin theta upon cos theta minus 1 is equal to 1 by 3. Okay? Can you solve this equation? Trigonometric equation. Do you understand till here? Okay. You could either do this, or you can find the equation of the straight line and you can make it intersect the circle. Okay. So equation of the straight line is actually x by 3 plus y upon minus 1 is equal to 1. So x minus 3y is equal to 3. And you have this circle. You can put the value of x from here, put it in here, you'll get a quadratic equation in y, solve it. That's the other way. Or we can do this. Okay. So now, what are you getting? Sin theta. Are you getting something? You cross multiply.
3 sin theta is equal to cos theta minus 1
Okay.
sin theta is equal to cos theta.
So 3 sin theta cos theta minus 1. So you get sin theta, or you get, let's say, cos theta. The value of cos theta is 3 sin theta plus 1. And we know that sin square theta plus cos square theta is equal to 1. Right? So sin square theta plus 3 sin theta plus 1 square is equal to 1. Okay. Open the brackets. You will get 10 sin square theta plus 6 sin theta is equal to 0. Okay. This 1 and 1 will cancel out. So the value of sine theta is either 0, okay, the value of sine theta is either 0 or it will be minus 3 by 5. Is it okay? So see that, say if you take sine theta common, you get so it is either 0 or it will be minus 3 by 5. Okay, so if you put this as 0, this becomes 1, 1 minus 1. But will there be a point? If the parametric coordinate is equal to 0, what is this point? It will be actually this point only, right? So we'll get this point again. Like if you put sine theta is equal to 0, you get this is 0 and this will be 1. So you get 3 comma 0, which is actually this point. So we have to check the other solution where theta sine theta is equal to minus 3 by 5. So if we put sine theta is equal to minus 3 by 5, what is the value of cos theta?
minus 9 by 5 minus 4 by 5.
Minus 4 by 5. Okay, so sine theta is minus 3 by 5, cos theta is minus 4 by 5. Okay, so you will easily get this point. This point will be minus 9 by minus 12 by 5 comma minus 9 by 5. Now can you find this area? What do you need to find? You need to find the area of triangle AMO. Okay, what will be the area? Anyone? Till here you understand? You understood how we got the value of sine theta?
Yes, sir.
Everyone?
Yes.
You understood how we get the value of cos theta?
Yes, sir.
You put this value of sine theta in here, you get the value of cos theta. So if you know the value of sine theta and cos theta, you get these coordinates by simply putting the values, right? And you get this triangle. Now you need to find the area of this triangle. What you will do is, you take this perpendicular, right? You know that area of triangle AMO will be equal to half base into height. What is the value of base? Base is 3 units, right? And what is the value of height? Height is 9 by 5, right? So area will be equal to area is equal to half base into height, which is equal to half 3 into 9 by 5. So even if you want to take minus sign, just take modulus over here, because area can't be negative, right? So this gives you 27 by 10. This is the answer. Okay, there are multiple ways of solving this equation, this problem. I use the parametric coordinates. You can use some other way. You'll get the same answer. Even if you solve it with this will not be tough. You know the equation of the straight line, you know the equation of the circle, right? Circle's equation is x square plus y square is equal to 9. So these are the two equations. Solve this equation simultaneously, right? You can put the value of y from here in here. You will get the value of x. Similarly, you can get the value of y. You will easily get this coordinate. Okay. So next, So write down the next question. Normal drawn to ellipse at the extremity of the lattice rectum passes through extremity of minor axis. Find its eccentricity. So this is a little typical question. This is a tough one. Try this out. First understand the question. So the ellipse, you can take standard x square upon a square plus y square upon b square is equal to 1. You're given nothing in here, right, except this condition. You have to use a square and b square, but the final answer of eccentricity which you are getting, that is a number. Okay, so it's a really typical type of question where no information is given, no value of a square b square is given. You have to form all the equations by yourself. क्या
तो ये एंड पॉइंट रिलेटिव सेक्टम से
हाँ
यहाँ से टैंजेंट हुई तो ये नॉर्मल यहाँ से
हम्म।
ये एंड पॉइंट सेमी माइनर एक्सिस
करेक्ट. Do you understand the statement? Have you drawn the figure? Everyone? Okay, so a standard ellipse what is the lattice rectum?
line passing through the focus.
A line passing through. Yeah, so double ordinate passing through focus. So first of all, make a lattice rectum. That should be your first target. Don't make any directrix or anything. Okay. Have you made the lattice rectum? Yes. It will be passing through the focus, right? This is a lattice rectum, and this is the end point of the lattice rectum, right? He's saying that the normal is passing through the extremity of the minor axis. So this is a figure which you need. So this is the equation of the normal. This is the normal, the shaded one, the scribbled one. Okay, and it is passing through the end point of the minor axis. Can you tell me what are the endpoints of the major this lattice rectum? No, not in parametric form. No, this is yeah, a comma b square upon a. Good. Now see, you remember the length of lattice rectum? Length of lattice rectum is 2b square upon a, right? So half of this lattice rectum is above the x-axis, half is below, right? So therefore this portion is b square upon a, this is b square upon a, right? So this point is, the y coordinate is b square upon a, this is minus b square upon a. And since this point is a comma 0, right? So the x coordinate is same. So this end point will be a comma b square upon a, right? And what is this? 0 comma, endpoints of minus axis will be 0 comma minus b.
Minus b.
Now take care of this, that don't put this point as 0 comma b, right? Since the normal can't pass through this point. If you take this point as a comma minus b square upon a, right? If you make this coordinate minus, then it will become plus. There can be two cases, right? So either the normal can be like this, okay, going like this, or it can go like this. Both of these are the endpoints. If this point is a comma minus b square upon a, this point will be 0 comma plus b. So these signs will be always reversed, always opposite signs. So now what can you do now? Now you know that this is the normal. What is the slope of a normal? Can you find this out? Can you find the slope of this normal? You know that slope of normal, what is the value? Now let's suppose the point is, the equation is x square upon a square plus y square upon b square is equal to 1. If you differentiate this, you will get 2x upon a square, 2y upon b square.
Equal to 0.
So dy by dx is
Minus ax minus b square x upon a square y.
so if this point is x1 comma y1, right? If this point is x1 comma y1, this will be the slope of the normal. So now you know how to derive this. Just differentiate it, okay, and then you can find the value of dy by dx. Okay, this thing is very useful. You will get a whole chapter on this thing. Application of derivatives, right? You remember?
Yes, sir.
That must be in your NCRTs as well. So now slope of normal will be equal to minus b square x1 upon a square y1. So minus b square, what is x1 over here? A minus b square ae upon a square b square by a. Okay, this a cancel, this a cancel, b square cancel. What is the slope of the normal? Minus e. Okay, understood? So the slope of this normal at the end point of the lattice rectum will be equal to minus time the eccentricity. Got this? Okay. Now you can equate this slope to, now he's saying that this is a slope, this is a normal at the end point of the lattice rectum, and it is also passing through this point, end point of the major axis. Now you can equate this e, this minus e, to the slope of this line, right? Since the normal is passing through this point, therefore the slope here will be equal to that slope of the normal, right? How do we find the slope of a chord? But simply 2-point form, y2 minus y1 upon x2 minus x1, right? And that is the slope of the normal that we found out with the help of the differentiation thing, right? So now, yeah, so slope of AB will be equal to b square upon a plus b upon a, and this is equal to minus e, right? So this is the slope of chord, and this we know is the slope of normal. Okay, you can equate these two and try to figure out how to find the eccentricity here. So whenever you're given a tangent or a normal is passing through some other point, right? Even if you remember in the case of parabola, we did the same thing, that the normal is passing through the parabola, the normal is cutting the parabola at some other point. What we did was, we equated the slope of that chord to the slope of the normal, and we got the relation between these 2 points. So this is the final equation. Okay, so there is one doubt here. A comma b square upon a, how do we get this? I think we derived this thing. If you have an ellipse, the equation is x square upon a square plus y square upon b square is equal to 1, right? This is the point focus. Now the lattice rectum is a perpendicular line to the axis which is passing through the focus. Perpendicular lines are known as double ordinates, right? So this is a double ordinate passing through the focus. So now the x coordinate will be same. Since this is a perpendicular line, the x coordinate will be same as AE. So if you put x is equal to AE, you will get a square e square upon a square plus y square upon b square is equal to 1. So y square is equal to b square 1 minus e square. If you put the value of e square, that is equal to, this is equal to 1 minus b square upon a square. So that means b square into b square upon a square. So y is equal to plus minus b square upon a. So after this it is simple calculation. You put the value of x is equal to AE in the equation of the ellipse, since this is point on ellipse, right? These endpoints of the lattice rectum lie on the ellipse. Therefore we put the value of x is equal to AE and get the values of y from here. So these are the values of y, b square upon a plus and minus. Okay. Now this is clear, I guess. How do we get this point as a comma b square upon a? Now see, next thing is, how does the slope of the chord equal to the slope of the normal? Now see, this is a normal. We know that in the question he was saying that the normal drawn at the end point of the lattice rectum. So normal drawn to the end point of the lattice rectum is this one. But this also passes through this point, which is the extremity of the minor axis, right? So at the end point of the lattice rectum, it meets the end point of the minor axis, right? Did we? Okay. So the slope, okay, let's write it down again. What was the slope we derived? Minus b square x1.
upon a square y1.
Okay, sorry. I keep doing this mistake. So this is the slope of tangent. Okay. So slope of normal will be equal to
a square y1 upon b square x1.
so just you will get this things reversed. So slope of AB, okay, this will be equal to 1 upon E then. Right? Since the slope of tangent was minus E, this will be equal to 1 upon E. Okay, now back to the same question. How do we get the slope equal to the slope of the normal? Now he is saying that this normal also passes through the end point of the minor axis. Therefore, it will satisfy this condition, right? That the slope of the line forming with these 2 points using these 2 extremities, extremity of lattice rectum, extremity of minor axis, the slope of this line should be equal to the slope of the normal, since it is the same line. Okay, is this okay now?
कैंसिल हो गया.
हाँ ठीक है. उसके बाद देखो, what are you getting?
a square minus b square is equal to ab.
A square minus b square is equal to AB. Yeah, correct. So finally, so is this clear? How the slope is same? If this is not clear, I'll explain again. If you say, so you get b square plus AB upon a square E is equal to 1 upon E. This cancel out. You get b square plus AB is equal to a square. B square plus AB minus a square is equal to 0. This is the equation, right? Now eccentricity cancelled out. You will not be able to find the value of eccentricity like this. You know that the formula for eccentricity is square root of 1 minus b square upon a square. So you need to find the value of b square upon a square here. You need to find the value of b square upon a square. But you know this equation. What will you do?
Divide by a square.
You divide this whole equation by a square. What will you get? B square upon a square plus b upon a minus 1 is equal to 0. Now this is the quadratic equation in b upon a. Can you find the value of b upon a? So the value of b upon a will be equal to minus 1 plus minus root 5 upon 2. Okay? It can't be equal to, it can't be negative, therefore this will be a plus sign. Minus 1 plus root 5 by 2. Got this? So you know the value of b upon a. Put it over here. Find the value of eccentricity. That will be your answer. Yes? Minus the coefficient of x. Oh, this is quadratic formula. Simple. Put b by a upon b by a is equal to t, let's suppose. So this is t square plus t minus 1. So the solution for this equation is minus 1 plus minus root 5 upon 2.
सर डायरेक्टली b square by a square की वैल्यू b और a की टर्म्स में रख के फिर वैल्यू
Yeah, you want the numeric value. You want the number. After this, you square this and put the value over here. You will get the answer. What? This one? Or this minus value? Because these both are lengths. B is also a length, A is also a length. Right? So B upon A is positive quantity. Since both lengths are positive. Okay.
सर हमने स्लोप ऑफ नॉर्मल और ए बी की स्लोप को इक्वल से बताना ताकि इक्वेशन आ जाए
Yeah. So that we form one equation, we just need one equation here. E cancel out and you form this equation. Now this is a trick. After this the question starts. You form this equation and then you try to figure out how can you get the eccentricity from here. Then you remember the formula for eccentricity is root 1 minus b square upon a square. Then you see if you calculate the value of b upon a, you can easily find the eccentricity. Okay. Question. Coordinate of a comma 0. What coordinate? The last question. Yeah, so the coordinate of focus are a comma 0, right? So if you have this is the point a comma 0, right? So this will be the end point of the lattice rectum, and this end point will be above or below this focus only, right? So if this point is a comma 0, this point is something a comma y1, and this is a comma y2. So our purpose to find the end point of the lattice rectum will be solved if we find the values of y1 and y2. And how can we find the values of y1 and y2? Just by putting the value of a in the equation of the ellipse. X square upon a square plus y square upon b square is equal to 1. Right? Since these 2 points lie on the ellipse, they will satisfy the equation of the ellipse. That's how we got the values of y1 and y2. Okay, this question is comparatively easy. What is the equation of normal in parametric form? We proved this. This is ellipses x square upon 5 plus y square upon 4 is equal to 1, right? So a square is 5, b square is 4. So what is the value of the what is the equation of the normal? Ax, what was it? Equation of normal minus by cos theta is equal to a square minus b square ax. So value of a is root 5 x sin theta minus 2y cos theta is equal to, what is a square minus b square? This will be equal to 1 sin theta cos theta. Just put the values of a and b. You will get the equation of normal, which is 5x sin theta minus 2y cos theta this is what you are getting. Okay, and you know the, now see, this normal is touching the parabola, right? What does that mean? That this line is the tangent to the parabola, right? Now write down the equation of tangent. Now see, when we started the chapter ellipse, we discussed two things. This is the center 0, comma 0. There are two things, focus and the directrix. This point has the coordinate a comma 0 and this point has the coordinate a by e comma 0. Right? This point here is a comma 0. Now since this focus is inside the ellipse, right? Therefore, the value of this coordinate should be lesser than a, right? Now eccentricity's formula is root 1 minus b square upon a square, which is less than a, less than 1, right? So therefore a times e will be less than a, which is some point inside the ellipse, and this point is actually called the focus, right? And we also derived that if this point is a comma 0, this point is a comma 0 and this point will be a by e comma 0. We derived this thing in the starting. I think you must have studied this in, you studied this, right, in your NCRTs. You have that thing, or you call it c comma 0.
Same.
You call it c comma 0, right? In the NCRTs it is written as c comma 0, but I will be writing it as a comma 0, because why to involve one more variables, right? So you can either put it as c comma 0, right, and then find the value of c. The value of c will be equal to a, okay? Or in some books it's written as root a square minus b square, or root b square minus a square minus b square, right? So the coordinates of this are written as, let's suppose, root a square minus b square comma 0. If you go by NCRT, they have written the coordinates like this, right? So if this is e, now you know the formula for eccentricity, that is equal to root 1 minus b square upon a square, right? And if you see the value of a, that will come out to be exactly the same as this, right? You can see it very easily. This will be root 1 minus b square upon a square, or this can be written as a square minus b square upon a square. If you multiply with this with a, you will get ae is equal to root a square minus b square. That is same as a comma 0, okay? That's why I am taking the value as a comma 0. If this is clear, just reply that is clear. Now see, this question is okay, right? What is the equation of the tangent of parabola? Y is equal to plus a by m. What is the value of a here? 1. So finally you get m square x plus 1 is equal to 0. Now this normal is same as this tangent, because he is saying that the normal is actually the tangent to the parabola. The normal to the ellipse is actually the tangent to the parabola. Therefore these two are identical, okay? Solve them, find the parameter theta, okay? How to solve such questions? Just compare the coefficients of x and y and the constant term, right? How do we compare? Root 5 sin theta upon m square is equal to 2 cos theta upon m is equal to minus sin theta cos theta upon 1, okay? From there you can get the value of sin theta cos theta. Sorry. Now see, these are the two values. These are the two equations. Equation of the same line. Therefore, root 5 sin theta upon m square is equal to 2 cos theta upon m is equal to minus sine theta cos theta. Okay. Now, what you will do now? You want to find the parameter theta, right? How will you find the parameter theta? See the value of m square from here. What is the value of m square? This is minus root 5 upon, what is the value of m? Okay, you can eliminate m from here. This is m square, this is m. Therefore, minus root 5 upon cos theta is equal to the square of this square, right? So you get root 5 sine square theta 4 cos theta. So sine square theta is
4 by root 5.
you form a quadratic equation in cos theta. Can you find the value of cos theta? Right? Or there's one more way. You can find the value of sine theta from here. Compare these two, right? You get sine theta is equal to, compare these two, you get minus m by 2 minus 2 by m. This is the value of sine theta. Cos theta's value is minus root 5 by m square, right? You take sine square theta plus cos square theta is equal to 1, right? From there you can get the value of m. After putting the value of m, you will get the value of trigonometric ratios. Where? Yeah. Okay. Now you can do it. Quadratic equation, simple to solve. So just find the value of cos theta, that will give you the answer. You need to find the parameter, right? So root 5 cos square theta minus 4 cos theta minus root 5 is equal to 0. So what is the value of cos theta? 4 plus minus square root of 16 plus root 5 5 into 4 20 upon 2. So what is this? 36. So this is 4 plus minus 6 upon 2. So you get two answers. One is 5 and minus 1. So two values of cos theta are possible, 5 and minus 1. Right? Are these both answers? Minus 1. Yeah. So 5 is not possible. Cos theta is equal to minus 1. Right? So put cos theta is equal to minus 1 here. Sin theta you can easily figure out. When cos theta is minus 1, sin theta is 0. Okay. So therefore sin theta is 0. Okay. That's all.